everyone, welcome to our demo of how we do declarative schema migrations using GitHub Actions and Atlas. So Atlas has been called a Terraform for databases, and the reason is that it provides a way to manage database schema in a declarative way. This means that the only thing that we need to do as developers is to change the desired state of our database, and we let Atlas figure out the rest. Let's see how this works. So I have here this schema.sql file. This represents the desired state of my application. This is a very simple content management system. In my browser, you will notice that I have this Neon serverless Postgres database that I'm managing as part of our demo. So let's say we want to create a new column in this table, and we'll call it the summary, and we will say that it's going to have to be not null. Okay, we want every post in our system to always have a summary. So add summary field. We are going to commit our change, add summary field, and to propose this change, we now create a new pull request. What happens when we create this pull request is that a GitHub action is triggered. This GitHub action runs a job called plan. Let's look at the code for the plan job to understand what it does. So you will see that when we create a pull request, we run this job. What it does is it sets up Atlas on the GitHub action runner and runs another GitHub action that is called schema plan. What schema plan does is that it will calculate the migration plan from the database at the URL that we provided here as a secret to this project that we just saw in our code. Once this action completes, we will see something very cool. We will see that Atlas comments on our pull request, and it tells us, I detected some changes, here is the migration plan. But how do we know if these changes are safe to apply? Well, thankfully, Atlas has an analysis engine that looks at the changes and analyzes them, give us some insights. And we see here that we found some issue with this change, because if we add a non-nullable text column without a default value, the migration might fail in case we have data in the table, because Postgres will not know what to do with the existing records. So let's remediate this. Let's add a default value for this field. We are committing this change again. Add default value for summary. Pushing this to GitHub, what we will see is that we re-trigger this GitHub action. Now, what happens now is very interesting. When Atlas detects this change, or GitHub Actions detects this change, it triggers the workflow. Now, as we saw, we run a GitHub action called schema plan, which basically compares between the state of the current database that we're managing, this Neon database, and the desired state of the schema as defined in the schema.sql file. When this finishes running, it will update the comment. And we see that now we are all green and good to go because no issues were found. Let's merge this. When we merge, we trigger a different workflow, which is responsible for pushing our schema and our plans to the Atlas schema registry. You can think about Atlas schema registry as a sort of Docker hub for your schema migrations. You can see here that we have the desired state of the database. We can see here the different plans and their status. And we will see that once this finishes running, we can see our schema in the schema registry. And if we look for our summary field, we will find it. Here. Okay. Now, at some point, we want to deploy our changes to production. So we created a new workflow and we trigger it. Let's look at the code for this workflow, for this deployment workflow. It does something very simple. It, of course, installs Atlas on the GitHub Actions runner, and then it runs the schema apply action. What it does, it's the URL for deploying is our Neon database, and it's using our new declarative workflow project that we can find here. This is the desired schema that we want. What happens during deployment is that Atlas is going to connect to the Neon database. Apologies, I think I ran the wrong action. Yes, let's run the deployment action this time. What happens is that Atlas runs, it connects to the Neon database, it inspects its information schema, it looks at the desired state of our database as defined in the schema registry, and calculates a fingerprint, a hash representing the from schema and the to, the desired and the current. What Atlas will do at runtime is it will look in the schema registry for a plan for this specific transition, okay, from moving from some specific state to another specific state. And only if such a plan is located will Atlas move forward into deploying. And we can see that Atlas connected to the database, it found an approved plan, and it executed our schema migration. Now, if we look at our target database, we can see in the posts table we should find the summary column has been created by Atlas.